I've just put my inverter, my and my OR on the board here, and I just wired my inputs over to my inverter. But how did I know how to do that? I have to look up the pinout of inverter chip, and that's not a secret either. And let's do an image search of an inverter, and I kind of like to put it in the same orientation as what I have on my board here. So here's a nice inverter chip. It says pin. That's not the chip I have. Let's see. I have a 7404. Here's a 7404. And it says that pin 1 is an input, pin 2. Here, let's just look at this one. Pin 1 is an input, pin 2 is an output, pin 3 is an input, pin 4 is an output. And there are 1, 2, 3, 4, 5, 6 inverters on this chip. So that's how I knew, because I did kind of remember that I can come into pin 1. When I come out of pin 2, that'll be an inverted A. So this is my A, this is my B. This is just plain A coming in. This is just plain B. I might want to put it in an inverter, or I might just want to pull from this line. Let's actually put them in just right here, because this is going to be A. Hopefully you can see this. This whole row is going to be A. This whole row is going to be B. This whole row is activated A. This whole row is activated B. All right, so I'm going to change this camera angle so that hopefully you can see a little bit better. Because we're going to build this just from our Boolean expression that we simplified at this point. We don't even need the screen anymore. So here we go. I came in, and all of this row 6 is going to be A, and row 8 is going to be B. Row 7 is going to be an inverted A because it went in pin 1 and out pin 2. So let's see. My OR gate, my big OR gate down here is going to want, my big OR gate is going to want some AND gates in it. It's going to want an AND gate from my AND gate pinout goes in, out. So there's an output of an AND gate. It'll want that output of an AND gate. I'll just go for a different size here. It'll want, so this is the OR gate here, is going to want the output of an AND gate to come in as an input. To come in as an input. There we go. Input is pin 1, 2, 3 in an OR gate. Output is input is pin 1, 2. Output of my AND gate is pin 3. So there we go. This AND gate took an output into the input of my OR gate. This AND gate, its output went into the OR gate. Now this AND gate needs its output to go into the OR gate. So let's do that one. Maybe I do that whole second gate in red. In, out. So it's going to be pin 6 is out. And in here. I want to go from pin 6 to pin 2 input of my OR gate. I'm going to strip this wire a little bit shorter. I like to strip the wires by holding them with my needle nose pliers because that makes them nice and sharp. It makes them nice and straight. And also I'm not strong enough to hold them. Hopefully this is a good length. Just really guessing at this point. I'm going to make this second circuit, the second AND gate circuit, red so that you can see the difference between the two circuits. And I'll build this one way over here. So here, in, out of the first one, another in, out of the second one, pin 6, and there's pin 6. And it's going to be the other input here. There we go. It's the other input. Ooh, I wanted a straight wire, but it's not so straight. Okay, so those are my two outputs of the AND gate going to this input. Now this input is just going to go to an LED, and the LED is going to go to ground. I'm going to look for the flat side of the LED. There's the flat side, and that LED is just going to go to ground. So that's an output of this whole circuit. It's got to be sort of a different color for me. So it's one OR gate we use. In, out is 1, 2, 3. So I'm going to go out. I'll just go over here because that's the length of a wire I have cut. And then I'm going to look for the flat side here by looking down on this. I see the flat side is here. Flat side needs to point to negative. I like to bridge the middle of my circuit board here. And then I need to connect that to negative. I need to connect that LED to negative. I'm going to do that with a tiny little jumper where I'm just going to jump. I'm just going to jump from here over to negative. So let me make myself a small jumper. Oops. Let me make myself a small jumper to jump over to negative. Bending 90 degrees with your needle nose pliers is always nice. There we go. I'm going to put that jumper in there over to negative. So I've wired up this OR gate in the middle here. This is my OR symbol. I have an input from an AND gate. I have an input from another AND gate, and I have an output going to an LED. Now, what goes into the first AND gate? The first AND gate gets A inverted B. Well, it looks like B is easier. A inverted B, and that AND gate I'm going to do in brown. So B is easier because B is not inverted. So I'm just going to steal B from right here. So I'm going to steal B from here, and I'm going to put that as an input here. So round about that length. And you can probably do this at exactly the same time as me, since I'm kind of building it real time and making my own wires. So I'm in, out. I want input B, all by itself. Here is B. It's not inverted. It's an input to this inverter, so it's not inverted yet. And that's what I want to go into an input of my AND gate. It's too big. And if you're building circuits, you're going to be doing the same thing. You're maybe a bit stronger than me, so you can do it a bit more proficiently. And there we go. It is my second input to that AND gate. Pin 2. I want to put it in pin 2. Your circuit's going to work. If you put it in pin 1, it's going to be fine. But there it is. I put it in pin 2. Kind of neat and tidy. And what goes into pin 1? Pin 1 gets an inverted A. Ooh, that's scary. Well, that's just an A that went through my inverter. That's just an A that went through the inverter. And we go through the inverter. We looked at the pin out. We go into pin 1 and we go out of pin 2 and it gets inverted. Because that's what we pay the inverter to do. And that's going to go into pin 1 of my AND gate. So let's see if I can do this first try. All right. So there's my inverted A, and it's going to go in right in here into pin 1. Of course, pin 1 happens on this whole row. So it's going into pin 1 of the AND gate. So now I have taken A inverted and B by itself. The output of that AND gate goes to an OR and then out to the LAD. Now the other input of the OR is the second AND gate, which exists in pin 4, 5, 6. So in pin 4 and 5, which are the inputs, I get plain old A ANDed with inverted B. Let's do plain old A first. And I chose that as a little red circuit. Let's do plain old A. Plain old A sits here. It sits in row 6 here. I can just take plain old A and put it in that second AND gate. This might be just the wire to do that. Plain old A sits in the second AND gate, which is pin 4, 5, 6. Second AND gate gets plain old A. Plain old A. Very much running out of room. I'm gonna power my inputs over here now. That's fine. It's the same thing, same row. Plain old A is in row 6. It needs to go into in, out, in. Plain old A can go into one of those inputs. Slightly long on my wire, and I don't like it slightly long. There we go. Plain old A going in. Plain old A goes into the input 4. 5 needs to take B inverted. B inverted because, again, let me write it again. AB or AB. A is inverted here. B is inverted here. Exclusive OR pattern. Apples, oranges, apples, oranges. Apples are inverted here. Oranges are inverted here. So right now I'm doing this inverted orange in red. It's going to be an inverted B. In, out, pin 1, 2, 3, 4. Pin 4 is the inverted B. That's got to go to this pin here, which is pin 1, 2, 3, 4, 5. In, out, 4, 5, 6. It has to go to pin 5. And it looks like it's exactly the right length. It looks like it's tiny bit big. Just like all of my wires. But there we go. It has to go from the inverted B over to this pin. This pin. In, out, in, out. Beautiful. Into the OR gate, out to the LAD. There we go. Now to prove my truth table is 0, 1, 1, 0 because it's exclusive OR. It excludes the last case there. It's not like an OR gate. Then I would have to convert. I would have to put these in and prove the truth table that way. I would plug into 1 and I would plug into 1 to do a 1, 1. I would plug 0, 0 to do a 0, 0. Here's a 1. Here's plugged in 1, 0. Here's plugged in 0, 1. That's how you prove your truth table. And in this case, it won't work because anyone who's looking at this will know it won't work. This is like if I hand you a cell phone and it has no battery in it. It has no power. I'm not powering these chips. So in order to power these chips, I'm going to put a big power bar over here. I'm going to attach it to my power supply, which is negative and positive and negative over here because I want my alligator clips to to be far away from each other. I don't want to do this on the same side. Technically I could, but my alligator clips would then have a party together and short circuit. So when I hook it up to my power supply. So I like putting my alligator clips separate there. Now this is going to be negative all the way down here. That's great, but it doesn't go over to here. So I need to connect it. Now I'm ready to power up these chips. Positive will bring power all the way here, but it won't go over here. So this side won't do anything good. So I always just power both of these sides. And then the last thing I'm missing is actually plugging in my circuits to power. This is a circuit, it's an electronic device. It has to be plugged in, just like your cell phone needs its battery or your laptop needs to be plugged in. This needs to be plugged in. This needs to be plugged in. This needs to be plugged in. Just like you plug in a blender, you don't expect it to go without plugging it in. How do we plug it in? We look at our pinouts, and our pinouts tell us, our pinouts remind us that power and ground are at pin 7 and pin 14. Can't do that right now, but maybe you want to see the dogs. There we go. And they're wondering what we're doing so late at night here. She's happy about it. He's wondering why I'm not preparing food. Where's your food? Food? Is there food? No food. There's no food. And they think this is all pretty weird. But anyway, the pinouts. Oh, my goodness, there's a cat here. And here you go. Pinouts, pinouts, pinouts. There you go. The pinouts say, oh my goodness. The pinouts say power and ground, pin 14, pin 7, always on all of these chips that we have. The pinouts, the pin 14 has to go to power and pin 7 has to go to ground. So I like making these little jumpers. You can see my other videos for techniques to wire properly and nicely. Here's some little jumpers that are going to jump pin 7 over pin 14 over to power. I like to keep them over at the edge here because they're not really part of the circuit. It's just plugging in. You don't want to look at your power cord on your laptop, do you? And then pin 7 is down here. 1, 2, 3, 4, 5, 6, 7. But it's not part of my circuit, so I don't want to mess up my beautiful circuit with that. I do have a problem here because I put a nice wire there that I'm going to have to take out, move over. There we go. Now I can get pin 7 to ground there. Pin 7 to ground. And then now this one's still not working because I haven't given it a ground. Don't try this at home. You can do something kind of bad here, but sometimes it has to be done. There you go. This is how you would wire an exclusive OR gate without an exclusive OR chip if you just have the basic chips. You have to do it with an AND gate, that 2 AND gates that go into an OR gate. And then you have to invert your apples and oranges, your A's and B inputs through this inverter. You have to take them plain from the input rows into each OR gate, and then you have to take them inverted from the outputs of this inverter into the AND gate, from there into your OR gate into your LED, and that is a nicely wired exclusive OR gate using basic gates with the associated simplification of algebra from a circuit that represented exclusive OR using only NAND gates from that circuit that used exclusive OR with only NAND gates. Hope you enjoyed. Thanks for coming to the indoor kitchen today. Say bye-bye to the doggies. Bye.